Hello, welcome to the demo video of our drawing automation software Spussist Draw, where we show you how you can use this application to automate the 3D modeling, the quotation generation, and the 2D detailing of a combiner box that is used in building solar panels. The current bottleneck for designers is that they have to generate a 3D model for every inquiry they get, because the placement of all the components differs from inquiry to inquiry. So what we have done here is to generate a master of all the components and allow the user to drag and drop the components into the system, wherein once all the components are placed, the system automatically generates the drawing. Let me show you how this is done. I initially drag and drop the base plate onto the system. It comes in and I place the base plate into the window. And now if you see the whole screen, the right hand side top has all the components. The left top has the screen which shows you where the components are going to be placed. The bottom left gives you the bill of materials. And the bottom right is a message screen where it shows you all your error messages that are required, all the placement rules that you want to define, and all the interference rules that you want to define can all be given in here. So basically, it not only allows you to drag and drop the components, it also checks if the components are placed in the right place, if there's enough gap between the switch and the fuse, or any other rules that you may want to set up. Now I'm going to drag and drop the components into the system one by one. So I'm going to start off by dragging a 4 fuse into my left and placing it. I have the main switch up in the center, and so drop a 2 fuse up over here on my right side. Okay, now if you see, the bill of material automatically gets populated as and when I drop the components. So I've got a 2 fuse, I've got a 4 fuse, a main switch, and a base plate into the system. And if you see the messages, it says that the fuses on the left side and the right side are not equal, so they're supposed to be equal, and there has to be at least 2 earth terminals. Currently there are 0, and there's no switch in place. So I take in the earth terminal and place that. That's one. I've got the other earth terminal. Placed up. Yes. And now I'll need another fuse, or a 2 fuse or a 4 fuse. So this is where you see the whole system works really well. So I can just move the components based on my requirement and place things, and I have some space here for the switch. Yeah. Now this is all the user has to do actually to complete the design. He's got the complete bill of material here, and there are no error messages, which means my placements are all right. There it goes. So if I want to say fine tune the whole assembly point of the installation, say for instance the main switch is placed at 174, I want it at 170, I can dynamically update that here, and if you see, it's going to change the system. So it's at 29, it changes to 30, just to make sure that everything is in place, and for you to dimension it and things like that. You could round off values over here, the X and Y position, and see if it sits right, fits properly. Yeah. Now that you've included all your components into the system and everything, I go on and you can generate the output. The output are 2 outputs, the SolidWorks model and the SolidWorks 2D drawing, and the costing sheet. So let's start off by showing you how you generate the 3D model. All you have to do is go and select on SolidWorks model. It will ask you where you want the whole file to be placed. So I'm making a new folder called. Now the system opens SolidWorks. It creates the 3D model of each and every component we've just placed here. it places the components at the exact location we've just dropped in over here, and it gives you the assemble model and the part drawing separately. And another feature is it's not only for any one type of the combiner boxes. You could have multiple types, you could have multiple options to be selected. In fact, you could have different suppliers' designs shown over here. So you could have their designs to inputted over here, so that you can select that I want supplier A's fuse to be placed in this particular design, so his dimensions would come in practically. So as you see, it generates each and every file, each and every component separately before it goes on and assembles the component. So that's the complete 3D model. So if you notice, the 3D model will be generated exactly the way you've created your design over here. So whatever you place here and wherever you place that over here will come out as a 3D model automatically in under it. And another advantage of the system is that it also automatically generates the 30 mm gap that each fuse goes in case there are 2 layers, at 90 mm in case of 3 layers. So all those details are also automatically generated, and you could define the type of output that comes out here in areas like that. And if you see, it also gives you a complete history of all the components with the assemblies, the mating, the distances and everything. So it's not just any in-hand model that's open, it's actually a model that's been modeled and created for you to make some minor additions or things that could be done just as another SolidWorks model. And apart from creating the 3D model, it also creates the 2D drawing of the whole system. As you see, it's again the same as we designed, with only the input and output signs and to use in your specific drawing template. And all this is automatically done in under a minute. Now that the 3D model and the 2D drawings are created, let me quickly show you how the casting sheet is. And the casting sheet is created over here. And as you see, it updates all the cells automatically, how many brackets are required, how many fuses are required, and the whole casting sheet is automatically done. Your view of cost will come up here, and your total cost will be shown here. You could have the sheet linked to your master template, which has all the current pricing of all the components, all the bought out components, all the raw materials, and you could also have calculations over here if you want to calculate a few things and for you to arrive at the final cost to quote. So basically it allows you to completely automate the process of assembling, generating a 3D model, generating a 2D drawing. You could have fabrication drawings set up and configured over here, which allows you to generate fabrication drawings. If you want some unfolded designs, you could have that too done. And also the casting sheet. So it gives you from inquiry to quotation in under 5 minutes, which normally takes anything from 4 to 20 hours right now. So thank you for watching our video. Please feel free to contact us if you require any information, and this can be of course implemented to any product across lines and industries. Thank you.